The warehouse in Kmerdorf sat quiet on the morning of January 12, 1943. Outside, snow covered the proving grounds where the German army had tested tanks and artillery for 2 decades. Inside, beneath harsh electric lights, 3 engineers from the Heereswahl Army Weapons Agency stood around a small boxy vehicle painted in olive drab. It had been captured 6 weeks earlier in North Africa, pulled from a wadi near Sidi Bouzid after its crew abandoned it during a hasty retreat. The recovery team had towed it back behind German lines. Intrigued by its odd appearance, it was smaller than a Kubel Wagen, simpler than anything they'd seen, and yet American forces seemed to have thousands of them. Now it sat in Germany's premier military research facility about to be dissected. Hauptmann Ernst Schneider, a mechanical engineer who had designed components for the Panzer Mark V, walked slowly around the vehicle. His boots echoed on the concrete floor. He carried a clipboard and wore the gray-green uniform of the Wehrmacht Technical Services. Beside him stood 2 civilian engineers from Daimler-Benz, men who had spent their careers perfecting automotive excellence, who understood that a proper military vehicle required precision, robust engineering, multiple redundancies. They had come expecting to confirm what everyone in the Reich already believed, that American equipment was crude, mass-produced garbage, the product of a nation that valued quantity over quality, that built everything quickly and cheaply, because Americans themselves were soft, undisciplined, incapable of the engineering rigor that German industry represented. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schneider placed his hand on the vehicle's hood. The metal was thin stamped steel, perhaps 1/16 of an inch thick, a good strike with a rifle, but would dent it. Opened the hood and stared at the engine. It was a 4-cylinder inline motor, flathead design, displacing 134 cubic in crude cast iron block, simple valve train. Everything about it looked agricultural, like something that belonged on a farm tractor, not a military vehicle. One of the Daimler engineers, a man named Friedrich Baer, actually laughed. This is what they bring to fight the Wehrmacht. Mein Gott, look at this engine. We built better motors in 1930. But Schneider didn't laugh. He was counting the parts, counting the fasteners, counting the number of different bolt sizes. His expression grew more serious. With each count, he moved to the transmission, a simple 3-speed manual with a 2-speed transfer case. He examined the suspension, leaf springs front and rear, the most basic design imaginable. He looked at the wheels, stamped steel, not even proper spoke wheels. Everything about this vehicle violated every principle of German engineering. And yet Schneider pulled out a specification sheet that intelligence had compiled from interrogations and captured documents. This vehicle, the Americans called it a Jeep, a name apparently derived from the military designation GP for general purpose, had been produced in staggering numbers. The sheet claimed over 100,000, had already been built with production accelerating. Ford and Willys Overland, 2 companies, churning them out in multiple factories. He looked back at the Jeep. A question formed in his mind, one that would haunt German military leadership for the rest of the war. How could something this simple, this crude, this fundamentally wrong by every standard of proper engineering be winning? To understand what those engineers saw when they examined that Jeep, one must understand the philosophy that governed German military manufacturing in 1943. It was a philosophy born from tradition, from pride, from a belief system that equated complexity with superiority. German engineering had dominated Europe for decades before the war. Mercedes-Benz produced the world's finest automobiles. Zeiss crafted optical instruments of unmatched precision. Krupp forged artillery that set global standards. This wasn't propaganda. It was measurable reality. A German camera lens truly was sharper A German machine. Tool truly did hold tighter tolerances. German craftsmen trained for years as apprentices before they were considered qualified. This excellence created a national identity. Germany saw itself as the land of Dichter, Anina, poets and thinkers, but also of engineers and scientists. The periodic table was partly organized by German chemists. The diesel engine was German. Rocket science, jet engines, synthetic materials. Germany led in all of these fields. This wasn't empty boasting. These were facts. When applied to military equipment, this philosophy produced vehicles like the Kübelwagen, Germany's equivalent to the Jeep. The Kübelwagen was designed by Ferdinand Porsche, a man who would become legendary in automotive history. Featured a rear-mounted air-cooled engine, independent suspension on all four wheels, and a body shaped by aircraft designers to minimize weight while maximizing strength. It was clever. It was sophisticated. It was German. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the Kübelwagen required skilled labor to build. Circled engine demanded precise machining. Its independent suspension used intricate swing axles and reduction gears. Vehicle took hundreds of man-hours to assemble. Quality control was rigorous. Components were inspected, measured, tested. Nothing left the factory unless it met specifications. This approach extended to everything Germany built. The Tiger tank mounted an 88mm gun of devastating accuracy and power, but each Tiger required 300,000 man-hours to produce. Its engine was a 23L V12 masterpiece that developed 700 horsepower. But it needed skilled mechanics to maintain and guzzled fuel at catastrophic rates. The Tiger was nearly invincible in combat. Germany built fewer than 1,400 of them in the entire war. The German military believed this was the correct approach. Wars were won by superior soldiers using superior equipment. One Tiger could destroy 5 American Sherman tanks. One Messerschmitt Bf 109 could shoot down multiple Allied fighters. One German division properly equipped and trained could defeat 2 or 3 Allied divisions. Quality would triumph over quantity. This belief was reinforced by early successes. In 1940, Germany had conquered France in 6 weeks. In 1941, German armored spearheads had driven 500 into the Soviet Union in the war's first month. The Blitzkrieg worked. Speed, violence, and superior equipment had overwhelmed numerically larger enemies. The Wehrmacht had proven that. Why would they change? By 1943, when that Jeep arrived at Kundorf, Germany controlled territory from the Atlantic coast to the Völa River, from Norway to North Africa. The Reich had conquered 2 continents. It had done so with armies that man for man and machine for machine were superior to anything their enemies fielded. The German soldier was better trained, better led, and better equipped. This was simply true. So when Hetman Schneider and his colleagues examined this crude American vehicle, they did so with the absolute confidence that German engineering philosophy was correct, proven by victory after victory. The Jeep, with its primitive engine and stamped steel body, was exactly what they expected from America. Quantity without quality, production without pride, vehicles built by a nation, and that didn't understand warfare. Schneider began his examination. Systematically, the way German engineers approached everything with methodical precision. He created a form with categories: engine, transmission, suspension, electrical system, body, overall assessment. Each category would receive detailed measurements, part counts, and quality ratings. The engine came out first. 4 men lifted it from the chassis. It weighed barely 400 pounds and placed it on a workbench. Schneider disassembled it completely, laying each component in organized rows, connecting rods, pistons, crankshaft, camshaft, valves. He measured everything with German calipers and micrometers, instruments accurate to thousandth of an inch. What he found was startling not because it was sophisticated, but because it was so deliberately simple. The engine block was a single iron casting with no separate cylinder sleeves. The crankshaft ran in just 3 main bearings, not the 5 or 7 found in German engines. The camshaft set directly in the block without separate bearing inserts. Everything was designed to be cast, not machined. The Daimler engineer pointed out each shortcoming. Look at this crankshaft. Counterweights. The vibration must be terrible. And these pistons cast aluminum, not forged. They'll fail under sustained high RPM. But Schneider was looking at something else. He was counting fasteners. The entire engine used only 7 different bolt sizes. 7. A comparable German engine used over 30 different specifications. He examined the oil filter, a simple cartridge that could be changed in seconds. German engines used complex filtration systems requiring partial disassembly to service. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The carburetor was a revelation. It was a single barrel unit, crude but accessible. Schneider could see how it worked just by looking at it. No hidden passages, no complex linkages. He timed himself disassembling it. 4 minutes. Reassembly. 6 minutes. A comparable German carburetor required specialized tools and training. He'd seen mechanics spend an hour adjusting them properly. The electrical system was equally crude. The generator produced just 30 amps. The battery was a standard 6V unit, but everything was mounted externally, easily accessible. Every wire was color-coded, and a simple diagram was stamped on a metal plate riveted to the firewall. A diagram as if the designers assumed the mechanics would be incompetent, needing pictures to understand what connected to what. Was almost insulting. German vehicles came with detailed manuals, yes, but they assumed the mechanic had proper training. They assumed expertise. This Jeep assumed nothing. It was designed for idiots. Schneider moved to the transmission and transfer case. Again, brutal simplicity. The gears were cut rather than ground, leaving visible tool marks. German gears were ground smooth after cutting, then often lapped for final precision. These gears looked agricultural, but they were also large, overbuilt with thick teeth that could absorb tremendous shock loads. The transfer case offered a 2-speed reduction, giving the Jeep exceptional low-range torque, but the mechanism was so simple, just a sliding collar and 2 gear sets that Schneider could see exactly how it functioned. No complex planetary gears, no intricate dog clutches. A farm boy could understand this by looking at it. By the end of the first day, Schneider had filled 20 pages with notes and measurements. The other engineers had grown bored and left. This was beneath them, examining American garbage. They had proper work to do. Real engineering projects that mattered. But Schneider stayed because with each measurement, each part counted, each system analyzed, a disturbing picture was emerging. This vehicle wasn't crude because American engineers were incompetent. It was crude because they had designed it. To be crude deliberately, intentionally. Every simplification was purposeful. Every reduction in complexity was calculated. And if that was true, it meant the Americans understood something about war that Germany had missed. Something fundamental, something that might explain why, despite German superiority in engineering, despite victories across 2 continents, the war was beginning to turn against them. Schneider spent the second day focused entirely on production analysis. Was the aspect that troubled him most. He requisitioned intelligence files on American automotive manufacturing, compiled from pre-war industrial surveys, reports from German businessmen who had visited Detroit, and recent analyses of captured equipment serial numbers. The Jeep before him bore a serial number indicating it was manufactured by Willys Overland in Toledo, Ohio in November of 1942. But intelligence indicated Ford was also building identical vehicles at plants in Michigan and New Jersey. Two companies, multiple factories, producing the exact same vehicle to interchangeable specifications. Schneider knew what this meant. The Americans had standardized everything. Every bolt, every bracket, every wire clip was identical regardless of which factory produced it, apart from. A Willys Jeep would fit perfectly on a Ford Jeep. This was mass production at a scale Germany had never attempted. He pulled production figures from the intelligence files. In 1941, Willys and Ford together had produced 48,000 Jeeps. In 1942, the number jumped to 159,000. Projections for 1943 estimated over 250,000. These weren't estimates from Allied propaganda. These were German intelligence calculations based on shipping manifests, factory size assessments, and serial number analyses. Schneider did the mathematics. Assuming 300 working days per year, American factories were producing over 800 Jeeps per day. Per day, he looked at the vehicle before him. Complex enough to be functional, simple enough to build in hours rather than days. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. He compared this to German production. The Q-Balvern, by contrast, was built at a rate of approximately 14,000 per year. Across all factories, the Americans were producing 18 times more light vehicles. 18 times. And this was just one vehicle type. Intelligence reports indicated similar production ratios for trucks, tanks, aircraft, and ships. But Schneider dug deeper. He examined the Jeep's parts individually, considering manufacturability. The body was stamped steel made from simple dies that could be operated by semi-skilled workers. Forming these panels required large presses, yes, but once the dies were made, production was fast. A German equivalent would have been hand-formed or required multiple complex stampings welded together. The frame was two parallel channel sections, cross, braced, simple to cut, simple to drill, simple to weld. Complex curves, no compound angles. A basic welder could assemble this in an The German equivalent featured tubular construction with carefully calculated stress points requiring skilled craftsmen to achieve proper alignment. The suspension mounting points were crude but robust. The spring shackles were heavy steel forgings over-engineered for strength. They looked agricultural because they were designed like agricultural equipment built to survive abuse by inexperienced operators. German suspensions were more sophisticated, yes, but they required adjustment and maintenance. These leaf springs required nothing. They either worked or they broke, and breaking them took extraordinary abuse. Schneider examined the wheels and tires. The wheels were stamped steel, 3 pieces. Welded together, crude but stampable on massive presses at high speed. The tires were bias ply size 7 to 100 by 16, nothing special but intelligence. Indicated the Americans had standardized this size across multiple vehicle types. The same tire that fit the Jeep also fit certain trucks. This meant simplified logistics, interchangeable spares. It moved to the engine again, this time analyzing it from a production standpoint. The cylinder block was a single iron casting. One piece poured in a mold, cooled, then machined. The machining required only basic operations: boring the cylinders, facing the deck, cutting the valve seats. Any machine shop could do this work. The cylinder head was another simple casting. The manifolds were cast iron, not fabricated steel. Every component was designed for mass production. Nothing required hand fitting. Nothing required adjustment by skilled craftsmen. The entire vehicle could be assembled by workers with minimal training using basic tools. Americans had even designed special wrenches combination tools that fit multiple fastener sizes, reducing the number of tools required. Weber had dismissed this as evidence of American incompetence. They designed for their workers' stupidity, it said. But Schneider was beginning to see it differently. The Americans weren't designing for stupidity. They were designing for scale. They were designing for an entirely different kind of war than Germany was fighting. He pulled out his notes from a lecture he'd attended in 1941 given by a logistics officer. The officer had calculated that Germany could sustain approximately 3 million men in the field with existing industrial capacity. This assumed normal attrition rates, standard equipment replacement schedules, and the full output of German factories plus occupied territories. The Americans, according to that same officer, could theoretically field similar numbers, but their equipment would be inferior, their logistics would be strained by the Atlantic crossing, and their soldiers would lack German training and discipline. Quality would defeat quantity. Schneider looked at the Jeep. The assumptions were wrong? What if the Americans could produce equipment faster than Germany could destroy it? Simplicity was actually strategic? On the 5th day of examination, Schneider compiled his findings into a formal report. Standard practice required him to submit it through channels to the Heereswaffen Technical Directorate, where it would be reviewed, summarized, and filed. But something about his conclusions troubled him enough that he requested a meeting with General Major Wilhelm